Hello and welcome to the channel, where we explore the quiet wonders that surround us every day. I'm so grateful you're here with me tonight. So, water, it flows from your tap, fills your glass, falls as rain against your window. So familiar, so essential, that we barely pause to consider it. But tonight, we're going to slow down and really look, really wonder. Because water, this clear, tasteless liquid that makes up most of your body, that carved the Grand Canyon and fills our vast oceans. Water is actually impossible. By every rule of chemistry and physics, it simply shouldn't exist, not as we know it, not behaving the way it does. Before we begin this gentle journey together, I'd love to ask a small favor. If this content brings you any sense of peace or wonder, a gentle tap on the like button helps this little corner of calm reach others who might need it too. And if you'd like to join our growing community of curious souls, the subscribe button is there waiting for you. I'm also genuinely curious. Where in the world are you right now? And what time is it where you are? There's something beautifully connecting about knowing we're sharing this moment across different places and time zones, like invisible threads weaving us together through the very substance we're about to explore. Feel free to share in the comments below. Now, close your eyes if you'd like, or let them rest softly, as we dive deep into the impossible miracle that is water. Why ice floats? The mistake that saved Earth. You're holding a glass of water on a warm afternoon, watching ice cubes bob gently at the surface like tiny glaciers in your drink. It's such a simple sight that you've probably never questioned it. But here's something that should make you pause. Those ice cubes are performing a miracle that defies the laws of almost everything else in the universe. When most things get cold, they shrink. They become denser, heavier, more compact. Drop a chunk of frozen metal into liquid metal, and it sinks like a stone. The same happens with wax, with oil, with nearly every substance we know. The solid version is always denser than the liquid version, except for water. Water is the rebel of the molecular world, the troublemaker that refuses to follow the rules. When it freezes, it expands. Those ice cubes in your glass are actually less dense than the water around them, which is why they float there so casually, as if weightlessness were the most natural thing in the world. But this isn't just a curious party trick of physics. This single, strange property of water, this molecular rebellion, may be the only reason you're alive to read these words. Imagine for a moment that water behaved like everything else. Picture a world where ice was denser than liquid water, where frozen water sank to the bottom instead of floating to the top. It sounds like a small change, doesn't it? Just a minor adjustment to the laws of physics. But this tiny difference would have created a world so hostile that life as we know it could never have taken hold. In this alternate reality, when winter came to Earth's lakes and rivers, ice would form and immediately sink to the bottom. More ice would form on the surface and sink again, layer after layer, until entire bodies of water froze solid from the bottom up. There would be no insulating layer of surface ice to protect the liquid water below, no refuge for fish, no liquid sanctuary for the microscopic organisms that form the foundation of life's great pyramid. The oceans themselves would become massive, frozen graveyards. Once the ice began accumulating on the ocean floor, it would never melt. The crushing weight of water above would keep it locked in its solid state. Slowly, inexorably, Earth's oceans would freeze into solid blocks of ice, trapping all their water and leaving the planet a barren desert world. But water chose a different path. Instead of contracting when it freezes, water molecules arrange themselves into a crystal lattice that takes up more space than their liquid form. It's as if they're holding hands in a circle, creating gaps between themselves that weren't there before. This expansion makes ice less dense, so it floats, creating that crucial insulating layer that keeps the water below from freezing. This seemingly backwards behavior happens because of water's unique molecular structure. Each water molecule's 2O, or as we might say for text-to-speech, H2O, is like a tiny magnet with a positive end and a negative end. When water freezes, these molecular magnets align themselves in a very specific pattern, a hexagonal crystal structure that forces them apart, making the solid form actually take up about 9% more space than the liquid form. Think of it like people in a crowded room. When they're moving around freely like liquid water, they can pack together quite tightly. But if you ask them all to hold hands in a very specific formation like ice crystals, Suddenly they need more room. Even though there are the same number of people, this molecular choreography created the perfect conditions for life to emerge and thrive on Earth. When lakes freeze over in winter, they form an insulating blanket of ice that protects the liquid water and all the life within it. From the killing cold above, fish swim lazily beneath this frozen ceiling. Frogs hibernate in the muddy bottom, and countless microorganisms continue their ancient dance of survival. The floating ice does something else remarkable. It reflects sunlight back into space. This helps regulate Earth's temperature, preventing our planet from becoming too hot. It's a delicate balance. Too much ice and we freeze. Too little and we cook. But water's strange expansion property helps maintain this equilibrium, creating a world that's just right for life. Indigenous peoples around the world have long understood the sacred nature of this phenomenon. The Inuit have dozens of words for different types of ice, recognizing that this solid water in all its forms is not just a physical substance, but a life-giving force. They knew, perhaps better than modern science, that ice floating on water was not merely a curiosity but a blessing that made their world possible. Even now, as climate change alters the delicate balance of ice and water on our planet, we're beginning to understand just how crucial this floating ice is to our survival. The great ice sheets of Greenland and Antarctica don't just store water, they reflect sunlight, moderate ocean currents, and maintain the climate patterns that have allowed human civilization to flourish. So the next time you see ice cubes floating in your drink, or watch icicles hanging from your roof, or witness the first ice forming on a winter pond, remember that you're witnessing one of the universe's strangest miracles. You're seeing the molecular rebellion that saved Earth, the beautiful mistake that made life possible. Water broke the rules of physics, not through chaos, but through an elegant molecular dance that created the perfect conditions for the emergence of consciousness itself. In a universe where most things behave predictably, water chose to be different. And in that difference, in that strange expansion when it should contract, lies the secret of why we exist at all. The day Earth almost froze over, and water fought back, there was a time, not so very long ago in Earth's vast timeline, when our planet nearly died, not from fire, not from asteroids, but from cold. A cold so complete and terrible that it turned Earth into a giant snowball, spinning through space like a frozen marble lost in the cosmic dark. This wasn't just any winter, this was the Snowball Earth period, roughly 7 million years ago, when ice stretched from the poles to the equator, when glaciers ground across what would one day become tropical beaches, when the oceans themselves began to freeze solid. For millions of years, Earth was locked in this icy prison, and life hung by the thinnest of threads. But here's the remarkable thing. Water itself may have been the key that unlocked this frozen world, and set the stage for the explosion of complex life that followed. Picture Earth during this frozen epoch. The sun rises over a landscape that would be alien to us, endless white plains stretching to every horizon, mountains buried under ice, miles thick, and an eerie silence broken only by the crack and groan of shifting glaciers. The oceans, those great blue highways of life, were covered by ice sheets that may have been hundreds of feet thick in some places. Yet beneath this frozen lid, something extraordinary was happening. Water, even in its most hostile form, was preparing for its greatest comeback. The story begins with what scientists call a runaway ice age. As more of Earth's surface turned white with ice and snow, more sunlight was reflected back into space instead of being absorbed as heat. This made the planet even colder, which created more ice, which reflected even more sunlight, in a devastating feedback loop that seemed impossible to break. But Earth had a secret weapon: volcanoes. Even during the deepest freeze, volcanoes continued to erupt, pumping carbon dioxide into the atmosphere. Normally, this CO2 would be absorbed by the oceans and by rock weathering processes. But with the oceans frozen and the continents buried under ice, there was nowhere for this volcanic carbon dioxide to go except to accumulate in the atmosphere. For millions of years, volcanoes slowly but steadily built up a greenhouse blanket of CO2 in the atmosphere, and water in its gaseous form as water vapor began to play a crucial role in amplifying this warming effect. You see, water vapor is itself a greenhouse gas. In fact, it's the most important greenhouse gas on Earth. As the volcanic CO2 began to warm the atmosphere even slightly, it allowed a little more water to evaporate from the ice, which trapped even more heat, which allowed even more evaporation. This was water fighting back against the frozen tyranny, molecule by molecule, degree by degree. The turning point came when the accumulated greenhouse gases finally overcame the reflective power of all that ice. As temperatures began to rise, something remarkable happened at the edges of the frozen oceans. The ice began to retreat, exposing dark ocean water that absorbed sunlight instead of reflecting it. This created another feedback loop, but this time working in favor of warmth rather than cold. But here's where water's strange properties became absolutely crucial. Remember how ice is less dense than liquid water? This meant that as the great ice sheets began to melt, they didn't just quietly dissolve. The transition from ice to liquid water involved a dramatic reorganization of molecular structure, those hexagonal crystal lattices collapsing into the more compact liquid form. This phase change released an enormous amount of stored energy, not just the heat energy required to melt ice, but the mechanical energy of all that structured crystal lattice suddenly becoming fluid. It was like the entire planet was undergoing a massive molecular revolution, with trillions upon trillions of water molecules breaking free from their rigid formations and flowing back into liquid life. The melting wasn't gradual and gentle. Scientific evidence suggests that Earth's emergence from its snowball state was rapid and violent. Ocean temperatures may have risen from freezing to as much as 40 degrees Celsius. That's over 100 degrees Fahrenheit in just a few thousand years. Imagine the planet-wide torrents of meltwater, the massive storms, the chaotic churning of newly liquid oceans mixing with the remaining ice. But from this chaos came opportunity. The rapid warming and the mixing of different water masses created new ecological niches, new chemical gradients, new possibilities for life. It was as if Earth had hit a great reset button, creating a blank canvas on which evolution could paint new masterpieces. And paint it did. Not long after the Snowball Earth episodes ended, life on Earth experienced what scientists call the Cambrian explosion, a rapid diversification of complex life forms that gave rise to most of the major animal groups we know today. Was this timing coincidental? Many scientists think not. The extreme conditions of Snowball Earth may have put tremendous evolutionary pressure on the simple life forms that managed to survive in refugia, perhaps around underwater volcanic vents, or in pockets of liquid water that remained unfrozen. When the ice melted and normal conditions returned, these hardy survivors found themselves in a world full of empty ecological niches, just waiting to be filled. Water had not just survived Earth's greatest trial by ice. It had emerged transformed, carrying within its flowing currents the genetic diversity and evolutionary innovations that would eventually lead to all the complexity of life we see today, including the consciousness that allows us to contemplate this ancient drama. The Snowball Earth episodes remind us that water is not just a passive medium for life, but an active participant in Earth's story. It can be destroyer and creator, prison and liberator, all depending on the delicate balance of temperature, pressure and chemistry that governs its transformations. Today, as we face our own climate challenges, the story of Snowball Earth offers both warning and hope. It warns us that Earth's climate system can undergo dramatic, rapid changes that reshape the entire planet. But it also reminds us of water's remarkable resilience and adaptability, its ability to find a way, even under the most extreme conditions, to flow toward life rather than death. In every glass of water you drink, in every raindrop that falls, in every cloud that drifts across the sky, you're witnessing the descendants of the water molecules that fought their way out of Earth's frozen prison 700 million years ago. They carry within them the memory of that great battle, the molecular wisdom of survival against impossible odds. Water didn't just endure Earth's snowball phase, it orchestrated the planet's escape from it, setting the stage for the incredible diversity of life that followed. In doing so, it proved that sometimes the most powerful force in the universe isn't fire or wind or earth, but the quiet persistence of H2O, flowing always toward the possibility of life. Water has no shape, but it holds the world together. There's something almost magical about watching water find its way. Pour it into a square container, and it becomes square. Tip it into a round bowl, and it flows into perfect circularity. Water has no shape of its own, no fixed form to cling to, yet it's one of the most powerful forces on Earth, carving Grand Canyons, moving mountains grain by grain, and literally holding our planet together. This shapelessness isn't weakness, it's water's greatest strength. Think about the last time you watched rain on a window. Those droplets don't just sit there passively. They seem to dance, to merge, to find paths down the glass that follow invisible highways of molecular attraction. What you're witnessing is water's remarkable ability to stick to itself and to other substances through forces so subtle yet so powerful that they shape the very landscape of our world. The secret lies in water's molecular personality. Each water molecule is like a tiny social butterfly, constantly reaching out to form connections with its neighbors. The oxygen atom in H2O has a slight negative charge, while the hydrogen atoms carry slight positive charges. This makes every water molecule a miniature magnet, with positive and negative ends that attract other water molecules like friends gathering at a party. These molecular friendships are called hydrogen bonds, and they're the reason water behaves so differently from almost any other liquid. Individually, each hydrogen bond is weak, much weaker than the bonds that hold the atoms within each molecule together. But water molecules form so many of these bonds and reform them so quickly when they're broken, that collectively they create a liquid with almost supernatural properties. Consider surface tension, water's ability to act like it has an invisible skin on top. You've seen this when insects walk on water, or when you've carefully filled a glass so full that the water bulges above the rim without spilling. This happens because the water molecules at the surface are holding hands so tightly with their neighbors that they create a flexible but strong membrane. But water doesn't just stick to itself. It has an almost promiscuous attraction to many other substances. This is why water climbs up the inside of a glass, creating that slight curve where the water meets the container. It's why water can flow upward through plant stems, defying gravity to carry nutrients from roots to leaves hundreds of feet above the ground. The water molecules are literally climbing, hand over hand, pulling each other up through microscopic spaces in an endless chain of molecular cooperation. This climbing ability, called capillary action, is how water moves through soil, how it seeps into the tiniest cracks in rocks, how it finds its way into every possible space. Given enough time, water can infiltrate solid stone, and when it freezes and expands, it can split mountains apart. The Grand Canyon wasn't carved by some dramatic cosmic event. It was patiently sculpted by water, molecule by molecule, over millions of years. Water's shapelessness allows it to be the ultimate infiltrator. It flows around obstacles, finds the path of least resistance, and yet never stops moving toward its goal. Ancient Chinese philosophers recognized this quality and made it central to their understanding of strength and persistence. The Tao Te Ching speaks of water as the softest thing in the world, yet nothing can surpass it in overcoming the hard and strong. But perhaps water's most remarkable shape-shifting ability is how it bends light. When you look at a straw in a glass of water and see it appear bent or broken, you're witnessing water's ability to change the very nature of reality as we perceive it. Light travels more slowly through water than through air, and this change in speed causes light rays to bend, creating optical illusions that have fascinated humans for thousands of years. This light-bending property, refraction, is why pools look shallower than they really are, why fish appear to be swimming in different places than where they actually are, and why rainbows form when sunlight passes through water droplets in the air. Each tiny droplet acts like a prism, breaking white light into its component colors, and painting the sky with arcs of impossible beauty. Water's relationship with light goes even deeper. Pure water is remarkably transparent, allowing light to pass through with minimal absorption. This transparency is crucial for life in aquatic environments. Sunlight can penetrate deep enough into oceans and lakes to power photosynthesis, the process that converts light energy into chemical energy and forms the foundation of nearly all food chains on Earth. Yet, water can also absorb certain wavelengths of light preferentially, which is why large bodies of water appear blue. Water molecules absorb red light more readily than blue light, so when sunlight penetrates deep water, the red wavelengths are filtered out, leaving the blue wavelengths to scatter back to our eyes. The ocean's blue isn't just reflected from the sky, it's water's own color, revealed when there's enough of it gathered together. This selective absorption of light also explains why water is such an effective moderator of temperature. Water can absorb enormous amounts of heat energy without its temperature rising dramatically, a property called high specific heat capacity. This happens because much of the energy goes into breaking and reforming those countless hydrogen bonds, rather than into making the molecules move faster. This thermal stability is why coastal areas have milder climates than inland regions, why your body temperature stays relatively constant despite changes in your environment, and why Earth's oceans act as a vast thermal buffer, moderating the planet's temperature and making complex life possible. Water's shapelessness extends to its ability to dissolve more substances than any other liquid. It's often called the universal solvent, and this isn't mere scientific exaggeration. Water molecules surround and separate the molecules of other substances, pulling them apart through sheer molecular sociability. Salt dissolves in water because water molecules crowd around each sodium and chloride ion, effectively isolating them from each other and keeping them suspended in solution. This dissolving power is how water moves nutrients through soil, how your blood carries oxygen and nutrients to every cell in your body, and how waste products are carried away. Life as we know it depends entirely on water's ability to create solutions, not just chemical solutions, but literally solutions to the problem of how to move materials from one place to another in a liquid medium. Indigenous cultures around the world have long recognized water's shape-shifting nature as something sacred. Many creation myths describe the world beginning as formless water, with all possibilities contained within its flowing depths. These ancient stories intuited something that modern science has confirmed. Water's shapelessness isn't emptiness, but potential, the ability to become whatever form is needed, to adapt to any container, to find any path, to connect any 2 points. Every time you turn on a faucet, you're witnessing millions of years of geological processes as water completes its endless cycle from ocean to cloud, to rain to river to ocean again. The water flowing from your tap has no fixed identity. It might have been part of a cloud yesterday, part of the ocean last month, part of a dinosaur's bloodstream millions of years ago. This is water's greatest mystery and its greatest gift. It has no shape of its own, yet it gives shape to everything else. It holds no fixed form, yet it holds the world together through the countless invisible threads of hydrogen bonds, capillary action, and dissolving power. In its very formlessness lies the secret of its strength, the ability to be exactly what the moment requires while never losing its essential nature as H2O. Water teaches that sometimes the most powerful way to hold something together is not through rigid structure but through flexible adaptation, not through resistance, but through flowing response to whatever container life provides. In its shapeless wisdom, water shows us how to be both completely yielding and utterly persistent, how to find strength, not in hardness, but in the endless willingness to change form while remaining true to our deepest nature. Ancient civilizations that knew water's secrets, long before laboratories and microscopes, before we understood hydrogen bonds or molecular structure, ancient peoples looked at water and saw something that modern science is only beginning to rediscover. Water isn't just a substance, it's a living system, a carrier of information, a bridge between the physical and the sacred. Walk along the Nile today, and you're following in the footsteps of a civilization that treated water not merely as a resource, but as a divine force that literally brought life from death. Every year the ancient Egyptians watched the great river rise and flood their land, leaving behind fertile black soil that transformed the desert into a garden. They didn't see this as mere geology. They witnessed the resurrection of the world itself, the daily miracle of life emerging from water. The Egyptians built their entire cosmology around water. In their creation myth, before anything existed, there was only none, the primordial waters of chaos and potential. From these waters emerged all of creation, and to these waters everything would eventually return. But none wasn't empty or lifeless. It was pregnant with all possibilities. Much like the quantum foam that modern physicists describe as the foundation of reality, the Egyptian priests developed elaborate rituals around water that modern science might dismiss as superstition. Yet, recent discoveries suggest they may have intuited something profound about water's ability to carry and transmit information. They believed that water blessed in their temples could heal the sick, that water from sacred sources held different properties than ordinary water, and that the act of speaking prayers over water could somehow change its essential nature. Thousands of miles away in ancient China, Taoist philosophers were developing their own understanding of water's mysterious properties. Lao Tzu wrote that nothing in the world is softer than water, yet nothing is better at overcoming the hard and strong. This wasn't just poetic metaphor, it was a sophisticated understanding of water's unique ability to shape reality through persistence rather than force. The Chinese developed the concept of water having memory and consciousness. They believed that water from different sources carried different qualities. Mountain spring water held the clarity and strength of peaks, river water carried the wisdom of the earth it had traveled through, and rainwater brought the energy of the heavens. Modern research into water's molecular structure suggests they may have been observing real differences in how water molecules organize themselves based on their journey and environment. Chinese medicine, which is thousands of years old, is built on the understanding that the human body is primarily a water system, and that health depends on the proper flow and quality of this internal water. They developed techniques for observing how water moves through the body, how it carries energy and information, and how blockages in this flow create disease. Modern medical research is beginning to validate many of these ancient insights about the role of cellular water in health and healing. In India, the ancient Vedic texts describe water as having consciousness and memory. The Rigveda, one of humanity's oldest sacred texts, contains hymns that speak to water directly, acknowledging its role not just in sustaining life but in carrying prayers and intentions. Hindu tradition holds that water can be charged with spiritual energy through mantras and ceremonies, a belief that finds interesting parallels in modern research into water's ability to form different molecular structures based on external influences. The sacred city of Varanasi, where millions of pilgrims come to bathe in the Ganges River, represents one of humanity's longest-running experiments in the spiritual properties of water. For over 3,000 years, people have believed that this particular water has the power to wash away sins and grant spiritual purification. While modern science might question the mechanism, the consistency of this belief across millennia suggests that these ancient peoples observed something about water that we're still trying to understand. Indigenous peoples across the Americas developed their own sophisticated understanding of water's sacred nature. Many Native American tribes speak of water as the first medicine, the substance that connects all life. Their ceremonies often involve offerings to bodies of water, recognizing rivers, lakes, and springs as living beings rather than mere resources. The Hopi people of the American Southwest, living in one of the world's most arid environments, developed an almost supernatural ability to find and work with water. Their agricultural techniques allowed them to grow crops in desert conditions by understanding how water moves through soil, how it can be conserved and directed, and how different plants can work together to create microclimates that retain moisture. These indigenous water practices weren't based on modern hydrology, yet they often achieved results that contemporary engineers struggle to replicate. The ancient Hopi understood that water responds to the landscape in complex ways, that it can be invited and encouraged rather than simply captured and controlled. Perhaps most intriguingly, many ancient cultures developed similar ideas about water's ability to carry information and intention despite having no contact with each other. Aboriginal Australians speak of songlines, invisible pathways across the land that are sung into existence and maintained through ceremony. Many of these songlines follow water sources, suggesting an understanding that water and information flow together through the landscape. The ancient Greeks, the founders of Western science, also recognized water's special properties. Thales of Miletus, often considered the first philosopher, declared that water was the fundamental substance from which all things emerged. While this might seem primitive compared to our modern understanding of atomic structure, Thales was observing something profound: water's unique ability to exist in multiple states and to serve as the medium for nearly all chemical reactions that sustain life. Greek temples were often built near sacred springs, and the Greeks developed elaborate rituals around these water sources. The oracle at Delphi, the most famous prophetic site in the ancient world, was located at a spring that the Greeks believed had special properties. Modern geological surveys have found that this spring does indeed have an unusual mineral composition that could potentially affect consciousness, suggesting that the ancient Greeks may have been more sophisticated in their observations than we initially realized. What's remarkable is how many of these ancient insights about water are finding validation in modern research. Scientists are discovering that water can indeed form different molecular structures based on its environment and history, that it can carry information in ways we're only beginning to understand, and that the human body's water systems are far more complex and important than previously thought. The ancient understanding of water as a living, conscious substance may not be as primitive as it first appears. These cultures observed water closely for thousands of years, noting patterns and properties that our modern instruments are only now beginning to detect. They developed practices and technologies based on these observations that often worked better than our contemporary approaches. Perhaps most importantly, these ancient peoples understood something that modern civilization has largely forgotten. Water is not just a resource to be consumed, but a teacher to be learned from, a sacred substance that connects all life in an endless web of circulation and renewal. As we face contemporary challenges with water scarcity, pollution, and climate change, the ancient wisdom about water's sacred nature becomes not just spiritually meaningful, but practically essential. These old cultures knew that healthy water systems require not just engineering, but reverence, not just management, but relationship. In every ancient tradition, water was seen as the bridge between worlds, between earth and sky, between life and death, between the physical and the spiritual. Modern science is beginning to discover that this intuition may have been more accurate than we realized. Water may indeed be the bridge between the world we can measure and the world of consciousness, information and meaning that we're still learning to explore. The secrets these ancient civilizations discovered about water weren't written in books but lived in practices, encoded in ceremonies, and passed down through generations of careful observation. As we continue to unlock water's mysteries with our modern tools, we might find that the ancients weren't just creating myths about water. They were documenting truths that we're only now sophisticated enough to understand. The water that's older than the sun. Every sip of water you take is a journey through time, not just the recent past, not just last week's rain or last year's snowmelt, but a journey that stretches back to the very beginning of everything. Some of the water molecules in your glass right now are older than the sun, older than our solar system, older than the Earth itself. They were born in the heart of ancient stars that died billions of years before our world even existed. This isn't poetic exaggeration. This is the stunning reality revealed by modern astronomy and chemistry. Water has been traveling through the cosmos for most of the universe's existence, carrying within its simple molecular structure the memory of stellar birth and death, the history of worlds beyond imagining. To understand how this is possible, we need to journey back to the very beginning of time itself. In the first moments after the Big Bang, the universe was far too hot and energetic for complex molecules to exist. Only the simplest elements could form, hydrogen and helium, with tiny traces of lithium. There was no oxygen yet, and therefore no water. The universe was a plasma soup of elementary particles, too chaotic for the delicate dance of molecular formation. But as the universe expanded and cooled, something beautiful began to happen. Gravity started pulling the primordial hydrogen and helium together into vast clouds, and these clouds began to collapse under their own weight. The compression generated heat, and eventually these collapsing gas clouds became so hot and dense at their centers that nuclear fusion ignited. The first stars were born. These early stars were cosmic furnaces, fusing hydrogen into helium in their cores, generating the light and heat that pushed back against their own gravitational collapse. But as these stellar furnaces burned through their hydrogen fuel, they began fusing helium into heavier elements: carbon, nitrogen, oxygen. For the first time in the universe's history, the ingredients for water were being created. When these massive first-generation stars exhausted their fuel, they died in spectacular supernova explosions that scattered their newly forged elements across space. The oxygen atoms that would eventually become part of water molecules were literally born in stellar fire and dispersed through the cosmos in stellar death. But the story doesn't end with stellar death. It begins there. In the cold, dark regions between stars, something remarkable started happening. The scattered oxygen atoms began encountering hydrogen atoms, the most abundant element in the universe, and in the frigid vacuum of space, they began to stick together. You might think that space is too cold and empty for chemical reactions to occur, but you'd be wrong. In the dense molecular clouds that drift between stars, temperatures drop to just a few degrees above absolute zero, and in these incredibly cold conditions, atoms move slowly enough that even the weakest attractions can cause them to combine. Grain by grain, molecule by molecule, water began forming in the cosmic darkness. These interstellar water molecules weren't liquid. Of course, they were ice, coating tiny dust particles, or existing as individual molecules drifting through the void. But they were water nonetheless. H2O, the same molecular combination that flows through your veins and fills Earth's oceans. Astronomers have now detected water throughout the universe. They've found it in stellar nurseries, where new stars are being born, in the atmospheres of planets orbiting distant suns, in comets flying through alien solar systems, and in galaxies so far away that their light has been traveling toward us for billions of years. Water, it turns out, is one of the most common molecules in the cosmos. Our own solar system formed about 4.5 billion years ago from a collapsing cloud of gas and dust, a cloud that was rich with water. Ice formed in previous generations of stellar evolution. As this cloud contracted and began spinning faster, it flattened into a disk with our young sun at the center and planets forming from the remaining material. The early Earth was a hellish world, bombarded by asteroids and comets, with a surface so hot that any water would have immediately vaporized and escaped to space. But those asteroids and comets were themselves carriers of ancient water ice that had formed in the depths of space billions of years earlier, preserved in the cold outer regions of our developing solar system. As Earth cooled and the bombardment lessened, this cosmic water began to accumulate. Some came from asteroids that struck our planet's surface. Some came from comets, essentially dirty snowballs from the outer solar system that delivered their ancient ice to our young world. Some may have been trapped in the rocks and minerals that formed Earth itself, only to be released later through volcanic activity. The water that filled Earth's first oceans was therefore a mixture of sources, but much of it had been wandering through space for billions of years before finding its way to our planet. When you drink a glass of water, you're consuming molecules that may have witnessed the formation and destruction of entire star systems, that may have drifted through interstellar space for eons before finally coming to rest in the gravity well of our small blue world. Recent discoveries have made this cosmic connection even more remarkable. Astronomers have found water in some of the oldest and most distant galaxies we can observe, galaxies as they existed when the universe was less than 1 billion years old. This means that water formation began very early in cosmic history, almost as soon as the first generations of stars had created enough oxygen to make it possible. The implications are staggering. Water isn't just a product of Earth's particular chemistry, it's a fundamental feature of cosmic evolution, forming wherever the right conditions exist throughout the universe. This suggests that the potential for life as we know it is woven into the very fabric of cosmic development. But here's perhaps the most mind-bending aspect of water's cosmic journey. Due to the constant recycling of matter through stellar formation and destruction, some of the water on Earth may be even older than our galaxy itself. The Milky Way formed through the merger and accretion of smaller galaxies, and water molecules that formed in those ancient separate galaxies may now be flowing in Earth's rivers and filling Earth's clouds. This cosmic ancestry gives new meaning to every raindrop, every ocean wave, every tear. We're not just connected to the cosmos through the chemical elements in our bodies. We're connected through the actual molecules of water that sustain us. The same H2O that cools your throat on a hot day once drifted in the cold darkness between stars, once witnessed the birth of alien suns, once traveled distances so vast that light itself takes millions of years to cross them. Scientists can actually trace some of this cosmic history through isotopic analysis, studying the ratios of different hydrogen and oxygen isotopes in Earth's water, and comparing them to water found in comets, asteroids, and other bodies in our solar system. Each source has a slightly different isotopic signature, like a fingerprint that reveals its origin and history. What they've discovered is that Earth's water comes from multiple sources, confirming that our planet's oceans are truly a cosmic mixture. Some water matches the isotopic signature of asteroids from the inner solar system, some matches comets from the outer reaches, and some appears to have come from sources we haven't yet identified. This cosmic heritage of water connects us not just to the history of our own solar system, but to the broader story of stellar evolution throughout the universe. Every time water changes phase from ice to liquid to vapor and back again, it's participating in physical processes that have been occurring throughout the cosmos for billions of years. The water cycle that we observe on Earth, evaporation, condensation, precipitation, is actually a local version of processes that occur on cosmic scales. Water evaporates from the surfaces of planets, condenses in the cold of space, and precipitates onto worlds throughout the galaxy. We are part of a vast interconnected system of water circulation that extends far beyond our single planet. When you watch clouds forming in Earth's sky, you're witnessing the same phase transitions that occur in the atmospheres of distant worlds. When you see morning dew condensing on grass, you're observing the same process that creates ice on the surface of asteroids. The water in your body is participating in cycles that connect you to the deepest history of the universe itself. This cosmic perspective transforms our understanding of water from a simple terrestrial resource to a fundamental feature of cosmic evolution, a molecule that has been present since the early epochs of star formation, a substance that connects worlds across space and time, a carrier of cosmic memory that links every living thing on Earth to the ancient history of the universe itself. In every drop of water lies the memory of stars that died before our sun was born, the echo of cosmic processes that shaped galaxies, and the promise that the same forces that created water in the depth of space continue to create possibilities for life throughout the universe. We are not separate from the cosmos. We are made of it, sustained by it, and connected to it through the ancient water that flows through our bodies and our world. Holy water, cursed water, when water becomes a portal. There's something that happens when human consciousness meets water that transforms both. Across every culture, in every corner of the world, water becomes more than H2O when it encounters belief, intention, and ceremony. It becomes a doorway, a passage between what we can touch and what we can only sense, between the physical world and realms that exist beyond our ordinary perception. Walk into any cathedral, temple, mosque, or sacred grove, and you'll find water waiting. Not just any water, but water that has been changed by human attention, blessed by ritual, charged with intention. To the rational mind, it's still the same molecular combination of hydrogen and oxygen. But to those who approach it with reverence, it has become something else entirely, a liquid bridge between worlds. The Catholic Church has used holy water for nearly 2,000 years, blessing ordinary water through prayers and intentions that believers say transform its spiritual properties. A priest makes the sign of the cross over a basin of water, speaks ancient words of consecration, and suddenly this water is believed to carry the power to bless, to heal, to protect, and to sanctify. Millions of people touch this water to their foreheads, drink it during ceremonies, or carry small vials of it as protection against spiritual harm. To skeptics, this might seem like elaborate superstition, but recent scientific research into water's molecular structure suggests something more intriguing might be happening. Water molecules are constantly forming and breaking hydrogen bonds with each other, creating temporary clusters and patterns that exist for brief moments before dissolving and reforming in new configurations. Some researchers theorize that these molecular patterns might be influenced by external factors we don't yet fully understand, including human consciousness and intention. Dr. Masaru Emoto's controversial experiments with water crystals sparked worldwide debate when he claimed that water could respond to human emotions and intentions. He exposed water to different words, music, and thoughts, then froze the water and photographed the resulting ice crystals under a microscope. Water exposed to positive words like love and gratitude allegedly formed beautiful, symmetrical crystals, while water exposed to negative words like hate and fear formed chaotic, irregular patterns. While Emoto's work has been criticized for lack of scientific rigor, it tapped into something that humans have intuited for millennia. Water somehow responds to consciousness in ways that pure chemistry cannot explain. Indigenous shamans, Hindu priests, and Islamic clerics have all developed elaborate ceremonies based on the belief that human intention can change water's essential properties. In Hinduism, water from the Ganges River is considered so sacred that millions of people travel thousands of miles just to bathe in it, or carry home small containers of this water. Believers hold that Ganga water, as it's called, can wash away sins, cure diseases, and even ease the transition from life to death. Hindu tradition says that even a few drops of Ganges water placed on a dying person's lips can help ensure a peaceful passage to the next world. What makes this water different from chemically identical water from other sources? The believers would say it's not about chemistry at all. It's about the consciousness and devotion that has been poured into this river for thousands of years. Every prayer, every offering, every act of reverence has somehow charged this water with spiritual energy that transforms its fundamental nature. Islamic tradition speaks of Zamzam water, drawn from a well in Mecca, that Muslims believe has been flowing since the time of Abraham. Pilgrims on the Hajj drink this water as part of their spiritual journey, and many take containers home to share with family and friends. Scientific analysis shows that Zamzam water has a unique mineral composition, but believers say its power comes from something that cannot be measured in a laboratory: the blessing of having sustained pilgrims and prophets for over 4,000 years. Buddhist temples often feature sacred springs or pools where monks have meditated for centuries. The water in these places is said to carry the peaceful vibrations of countless hours of contemplation and prayer. Visitors drink this water not just for physical refreshment, but for spiritual purification, believing that it can calm the mind and open the heart to deeper understanding. But water doesn't always carry positive charges. Throughout history, humans have also feared water that has been cursed or contaminated by negative intentions. Folklore from around the world speaks of wells that have been poisoned not just chemically but spiritually, of rivers that have turned malevolent after witnessing too much violence, of springs that have gone dry when communities have lost their connection to the sacred. The Salem witch trials included accusations that suspected witches had cursed local water supplies, causing illness and crop failures. While we now understand that waterborne diseases and environmental factors were likely responsible for these problems, the community's belief in cursed water was so strong that it contributed to the execution of innocent people. In West African traditions, water spirits called Mami Wata are believed to inhabit rivers, lakes, and oceans. These spirits can be benevolent, bringing healing and prosperity to those who honor them properly. But they can also be dangerous, causing drownings, floods, and spiritual possession when they're offended or ignored. Elaborate ceremonies are performed to maintain good relationships with these water spirits, acknowledging that water is not just a physical substance, but a conscious entity with its own desires and intentions. Native American traditions speak of water as one of the 4 sacred elements, a living being that must be approached with respect and gratitude. Many tribes perform water ceremonies to honor the spirits that live in rivers, lakes, and springs. These ceremonies aren't just symbolic, they're believed to maintain the spiritual health of the water itself, ensuring that it continues to support both physical and spiritual life. Modern science is beginning to explore whether there might be some physical basis for these ancient beliefs about water's ability to carry information beyond its chemical composition. Research into water's molecular structure has revealed that it's far more complex and dynamic than previously thought. Water molecules don't just float around randomly. They form temporary networks and clusters that can persist for brief periods before dissolving and reforming. Some researchers theorize that these molecular networks might be able to store and transmit information in ways similar to biological systems. If this is true, then water exposed to different environments, intentions, or energies might indeed develop different molecular patterns that could potentially affect how it interacts with living systems. The field of homeopathy is based entirely on the premise that water can retain the memory of substances that were once dissolved in it, even after those substances have been diluted away completely. While conventional science largely rejects homeopathic claims, millions of people worldwide swear by homeopathic remedies, suggesting that something significant, whether physical, psychological, or spiritual, is happening when water is treated as more than just H2O. Quantum physics has revealed that consciousness and observation can influence physical systems in ways that classical physics cannot explain. The famous double-slit experiment shows that subatomic particles behave differently when they're being observed versus when they're not. If consciousness can affect the behavior of elementary particles, is it so far-fetched to think it might also affect the molecular organization of water? Perhaps the most intriguing aspect of holy water traditions is their universality. Despite having no contact with each other, cultures around the world independently developed the belief that water can be charged with spiritual energy through human intention and ceremony. This suggests that humans are observing something real about the relationship between consciousness and water, even if we don't yet have the scientific framework to understand it fully. In Japanese Shinto tradition, purification with water is one of the most important spiritual practices. Before entering a shrine, visitors wash their hands and mouth at a sacred fountain, symbolically cleansing themselves of spiritual impurities. But this isn't just symbolic. Practitioners believe that the blessed water actually removes negative energy and prepares the soul for communion with the divine. The ancient Greeks built their most important temples near sacred springs, believing that these waters carried direct connections to the gods. The oracle at Delphi, the most famous prophetic site in the ancient world, was located at a spring that the Greeks believed had special powers to induce visions and divine communication. What all these traditions share is the understanding that water is not just a passive medium, but an active participant in spiritual processes. Whether through blessing, cursing, meditation, or ceremony, human consciousness appears to interact with water in ways that change both the water and the consciousness that encounters it. Modern research into the effects of prayer and meditation on physical systems has produced intriguing results. Studies have shown that people can influence the growth of plants, the behavior of random number generators, and even the healing rates of patients through focused intention, suggesting that consciousness might indeed have measurable effects on physical reality. If consciousness can influence these systems, then the ancient belief that it can also influence water begins to seem less like superstition and more like an observation of a real phenomenon that we're only beginning to understand. Every time someone blesses water, curses water, or treats it as sacred, they might be participating in a genuine interaction between consciousness and matter that science has yet to fully explain. The holy water in your local church, the blessed water at a Hindu temple, the sacred spring water carried home by a pilgrim, these might all be examples of what happens when human consciousness meets H2O with intention and reverence. Whether the change is in the water itself, in the consciousness that encounters it, or in some mysterious interaction between the two, the result is the same. Water becomes a doorway, a portal between the world we can measure and the world we can only experience through faith, hope, and wonder. In every drop of blessed water lies the possibility that consciousness and matter are more intimately connected than we've imagined, that intention and reverence might be as real and measurable as temperature and pressure, and that the ancient human instinct to see water as sacred might be pointing toward truths about reality that our instruments are only beginning to detect. Can water hear you? The bizarre experiments of Dr. Emoto. In a small laboratory in Japan, a man named Masaru Emoto was having conversations with water. Not metaphorically, literally. He would speak to containers of water, write words on pieces of paper and tape them to glass bottles, play different types of music to samples of distilled water. Then, He would freeze the water and examine the resulting ice crystals under a microscope, documenting what he claimed was water's visible response to human consciousness. What he found would either revolutionize our understanding of matter and consciousness, or serve as one of the most elaborate examples of wishful thinking in modern pseudoscience. The jury is still out, but the implications of Moe's work are too extraordinary to ignore. Dr. Moe's method was deceptively simple. He would expose water samples to different words, images, music, or thoughts, then freeze the water rapidly and photograph the ice crystals that formed. According to his documentation, water exposed to positive words like love, gratitude, and peace formed beautiful, symmetrical, snowflake-like crystals. Water exposed to negative words like hate, war, and fool formed chaotic, irregular, sometimes grotesque patterns. The most famous of his experiments involved 2 containers of rice and water. One container was labeled "Thank you" and spoken to with gratitude each day. The other was labeled "You fool" and subjected to verbal abuse. The third container was simply ignored. After several weeks, according to Emoto, the thank you rice remained white and began to give off a pleasant, sake-like fragrance. The "You fool" rice turned black and rotted. But most disturbing of all, the ignored rice turned moldy and began to decay, suggesting that indifference might be even more destructive than hatred. To the scientific community, Emoto's work was immediately suspect. His experiments lacked proper controls, his methodology wasn't standardized, and his results weren't independently replicated. Critics pointed out that he selected which crystals to photograph, that ice crystal formation is affected by numerous physical variables, and that his work had never been published in peer-reviewed journals. But something about Emoto's claims resonated with people around the world. His books became bestsellers, translated into dozens of languages. Parents began speaking more kindly to their children, remembering that young bodies are roughly 70% water. Musicians wondered if their performances were literally changing the water in their audience's bodies. People started blessing their drinking water, treating it not as an inert substance, but as something that might somehow be listening. The scientific establishment's rejection of Emoto's work might have ended the story there, except for one problem. Other researchers have found evidence that consciousness might indeed affect physical systems in ways that mainstream science doesn't yet understand. Dean Radin, a researcher at the Institute of Noetic Sciences, conducted double-blind studies of Emoto's claims using more rigorous methodology. In his experiments, people meditated on water samples while focusing on intentions of love and gratitude, while control samples received no such treatment. Independent judges then rated photographs of the resulting ice crystals for aesthetic appeal and structural coherence, without knowing which samples had received treatment. The results were statistically significant. Water that had been the focus of loving meditation produced more aesthetically pleasing and structurally coherent crystals than control samples. The effect was small, but it was measurable and repeatable. Even more intriguingly, the effect seemed to be stronger when the meditators were more experienced and when they felt more connected to the water they were treating. These findings don't prove that water has consciousness or memory in any conventional sense, but they do suggest that the relationship between consciousness and matter might be more complex than we've assumed. If focused human attention can measurably affect the crystal structure of ice, even under controlled laboratory conditions, then perhaps Emoto's more dramatic claims deserve further investigation, rather than immediate dismissal. The theoretical framework for how consciousness might affect water remains largely speculative, but several possibilities have been proposed. Quantum mechanics tells us that the act of observation can influence the behavior of subatomic particles. If consciousness plays a role in quantum processes, and if quantum effects can cascade up to affect molecular organization, then it's conceivable that focused intention could influence how water molecules arrange themselves. Water's molecular structure is extraordinarily dynamic. Individual water molecules are constantly forming and breaking hydrogen bonds with their neighbors, creating temporary clusters and networks that exist for fractions of a second before dissolving and reforming in new patterns. This molecular dance is sensitive to temperature, pressure, electromagnetic fields, and the presence of other substances. It's possible that it might also be sensitive to more subtle influences that we don't yet understand. Some researchers have proposed that water might be able to store information in the temporary patterns formed by these molecular clusters, a kind of liquid memory that could be influenced by external factors including human consciousness. This would explain not only Emoto's findings, but also the traditional beliefs about holy water, homeopathic remedies, and the healing properties of water from sacred sources. Dr. Jacques Benveniste, a French immunologist, created a scientific scandal in the 1980s when he claimed that water could retain the memory of substances that had been dissolved in it, even after those substances had been diluted away completely. His work was published in the prestigious journal Nature, but when other researchers failed to replicate his results under controlled conditions, he was dismissed from his position and his career was effectively destroyed. Yet, Benveniste's work has never been definitively debunked. Recent research by Nobel Prize winner Luc Montagnier has provided new evidence that water might indeed be able to store and transmit information about dissolved substances through electromagnetic signals. Montagnier's experiments suggest that the molecular structure of water can be influenced by extremely weak electromagnetic fields, and that these structural changes can persist even after the original source of the field is removed. If water can be influenced by electromagnetic fields, then it's worth considering whether human consciousness, which certainly involves electromagnetic activity in the brain, might also be able to affect water's molecular organization. The human brain generates complex patterns of electrical activity that create measurable electromagnetic fields extending beyond the skull. Could these fields somehow influence the behavior of water molecules in ways that become visible when the water is frozen into crystal form? Indigenous traditions around the world have long held that human thoughts and emotions can affect the natural world, including water. Native American water ceremonies involve speaking to rivers and lakes as living beings, asking for their help and blessing their flow. Hindu traditions speak of charging water with mantras, sacred sounds that are believed to alter the water's spiritual properties. These practices suggest that humans have been intuitively aware of some kind of interaction between consciousness and water for thousands of years. The implications of Emino's work extend far beyond laboratory curiosities. If human consciousness can indeed influence water, then every interaction we have with the natural world takes on new significance. The way we think about rivers, lakes, and oceans might literally affect their health and behavior. The words we speak and the emotions we feel might be changing the water in our own bodies, which in turn affects our physical and mental health. Consider that the adult human body is approximately 60% water. If this water can be influenced by consciousness, by our thoughts, emotions, and intentions, then practices like prayer, meditation, and positive thinking might have literal physical effects that go beyond psychology. The water in our cells might actually be reorganizing itself in response to our mental states, creating physical changes that we experience as improved health, greater energy, or enhanced well-being. Dr. Emoto himself believed that his water crystal experiments revealed a fundamental truth about the nature of reality, that consciousness and matter are interconnected in ways that transcend the traditional boundaries between mind and body, between observer and observed. He saw his work not as an attack on scientific materialism, but as an expansion of it, a demonstration that the universe might be far more responsive to consciousness than we've previously imagined. Critics continue to argue that Emoto's findings can be explained by confirmation bias, selective reporting, and the human tendency to see patterns where none exist. They point out that ice crystal formation is affected by numerous physical variables and that it's possible to find beautiful or ugly crystals in any sample if you look hard enough. But even if Emoto's specific claims about water crystals prove to be overstated, his work has opened up important questions about the relationship between consciousness and matter. If focused human attention can have measurable effects on physical systems, as suggested by research in fields ranging from quantum mechanics to psychoneuroimmunology, then perhaps we need to expand our understanding of what it means to be conscious beings in a material universe. The real question isn't whether water can literally hear us in the way that humans hear sounds. The question is whether consciousness and matter interact in ways that we don't yet fully understand, and whether these interactions might be visible in phenomena like ice crystal formation, plant growth, healing processes, and other systems that seem to respond to human intention and attention. Every time you drink a glass of water, every time you take a shower, every time you swim in a lake, or walk in the rain, you might be participating in a conversation between consciousness and matter that science is only beginning to explore. Whether that conversation is real or imagined, physical or metaphysical, it represents one of the most intriguing frontiers in our understanding of what it means to be conscious beings in a universe that might be far more alive and responsive than we've ever dared to imagine. Dr. Emoto's legacy lies not in proving that water has consciousness, but in suggesting that consciousness itself might be a more fundamental feature of reality than we've assumed, woven into the very fabric of existence, waiting to be discovered in every drop of water, every crystal of ice, every moment of focused attention between a human mind and the mysterious substance that makes life possible, the cities that disappeared into water. Beneath the waves, hidden in the depths of oceans and lakes around the world, lie the remnants of human civilizations that once thrived on dry land. These aren't just the ruins of coastal cities claimed by rising seas. These are entire urban centers, temples, palaces, and harbors that seem to have vanished into water as if the earth itself had opened up to swallow them whole. The most famous of these lost cities exists more in legend than in archaeological fact, yet it has captured human imagination for over 2,000 years. Atlantis, as described by the ancient Greek philosopher Plato, was a mighty island civilization that possessed advanced technology and wisdom far beyond its time. According to Plato's account, Atlantis was larger than Libya and Asia combined, with magnificent palaces, elaborate canal systems, and armies that conquered much of the known world. But the Atlanteans grew corrupt and greedy, and the gods punished them by causing their entire island to sink beneath the Atlantic Ocean in a single day and night. Plato wrote that Atlantis disappeared around 9600 BCE, leaving behind only an impassable muddy sea where the great civilization had once flourished. For centuries, scholars have debated whether Plato intended Atlantis as literal history or philosophical allegory, but the story has proven remarkably persistent, inspiring countless expeditions to find the lost city and spawning theories that place Atlantis everywhere from the Mediterranean to Antarctica. What makes the Atlantis story so compelling isn't just its dramatic destruction, but its suggestion that advanced civilizations have risen and fallen throughout human history, leaving only traces beneath the waves. And remarkably, archaeology has begun to confirm that many such civilizations actually existed. Off the coast of India, in the Gulf of Cambay, marine archaeologists have discovered the remains of what appears to be a massive underwater city. Sonar imaging has revealed geometric structures covering an area of nearly 9 square kilometers, including what look like huge walls, roads, and step-like structures that could be pyramids or temples. Artifacts recovered from the site have been dated to over 9,000 years old, making this underwater city contemporary with Plato's fictional Atlantis. The implications are staggering. If these structures are indeed the remains of an ancient city, they would predate the oldest known urban civilizations by thousands of years. They would suggest that complex, organized societies existed during the end of the last ice age, when sea levels were much lower than they are today. As the ice sheets melted and oceans rose, these coastal civilizations would have faced a choice: retreat inland or be swallowed by the advancing waters. Many may have chosen to flee, carrying only what they could transport, and leaving behind the massive stone structures that were too large to move. Over thousands of years, these abandoned cities would have been claimed by the rising seas, preserved in the cold, dark depths where oxygen levels are too low for rapid decay. In the Mediterranean off the coast of Egypt, archaeologist Frank Goddio has discovered the remains of 2 lost cities that were legendary even in ancient times: Heracleion and Canopus. These were major ports of ancient Egypt, mentioned in classical texts and visited by famous figures including Cleopatra and Julius Caesar. Yet for over 1,000 years their locations were completely unknown. Using advanced underwater scanning technology, Goddio's team found the cities lying under 30 feet of water in the Bay of Abukir. The preservation was extraordinary: temples with their walls still standing, massive statues of gods and pharaohs lying on the sandy bottom, ships with their cargoes intact, even delicate golden jewelry and religious objects. What destroyed these thriving cities? The evidence suggests a combination of earthquakes, soil liquefaction, and gradual submersion as the land sank and sea levels rose. The Nile Delta, where these cities were located, is geologically unstable, prone to sudden shifts that can cause entire sections of coastline to drop several feet in a matter of moments. But perhaps the most mysterious of all underwater ruins lies off the coast of Japan, near the island of Yonaguni, discovered in 1987 by dive tour guide Kiichiro Aratake. The Yonaguni Monument is a massive stone structure that rises over 70 feet from the ocean floor. Its surfaces are covered with what appear to be terraces, steps, platforms, and even carved figures that some interpret as ancient statues. The structure is so geometrically precise, so clearly architectural in its design, that many researchers believe it must be artificial, the remains of a sophisticated civilization that existed when sea levels were much lower. If the Yonaguni Monument is indeed man-made, it would be over 10,000 years old, built when the area was still above water. Other scientists argue that the monument is a natural formation, carved by underwater currents and geological processes rather than human hands. The rock-type sandstone is known to fracture along straight lines, and the ocean environment could have gradually carved away softer sections while leaving the harder stone intact. Yet the more closely researchers examine the monument, the more puzzling it becomes. There are features that seem almost impossible to explain through natural processes alone: perfectly straight edges, right-angle turns, circular holes that appear to have been drilled, and step-like formations that seem too regular to be accidental. Professor Masaaki Kimura of the University of the Ryukyus has spent decades studying the monument, and he's convinced it's artificial. He points to carved symbols, tool marks, and architectural features that he believes prove human construction. If he's right, the Yonaguni monument represents evidence of a sophisticated prehistoric civilization that possessed advanced stoneworking skills thousands of years before such capabilities were thought to exist. These underwater discoveries are forcing archaeologists to reconsider the timeline of human civilization. The traditional narrative suggests that complex societies began developing around 5,000 years ago with the rise of Mesopotamian city-states. But if the underwater ruins off India, Japan, and other locations are truly artificial, they suggest that sophisticated civilizations existed much earlier, and that many of their achievements were lost when rising seas claimed their coastal settlements. The end of the last ice age between 15,000 and 8,000 years ago was a period of dramatic climate change as massive ice sheets melted, sea levels rose by over 400 feet, flooding vast areas of previously habitable coastline. Some researchers estimate that millions of square miles of land that were once dry and potentially populated are now underwater. If early human civilizations preferentially settled along coastlines, as most modern cities do, then the majority of their ruins would now lie beneath the sea. We might be looking for evidence of early civilization in all the wrong places, searching for artifacts on modern land surfaces, while the real evidence lies hidden under hundreds of feet of water. The implications extend beyond archaeology into mythology and cultural memory. Stories of great floods that destroyed earlier civilizations exist in cultures around the world, from the biblical account of Noah's flood to similar tales in Mesopotamian, Hindu, Native American, and Australian Aboriginal traditions. Could these flood myths be cultural memories of real events, passed down through thousands of generations as oral history? The Aborigines of Australia tell stories of the Dreamtime when sea levels were much lower, and the coastline extended far beyond its current boundaries. Their oral traditions describe watching the sea gradually rise and claim familiar landmarks. Stories that modern geology confirms are accurate descriptions of post-glacial sea level rise. Similarly, many Pacific island cultures have legends of sunken lands and lost kingdoms beneath the waves. These stories often include specific details about the locations and features of the underwater ruins, details that suggest they might be based on actual memories rather than pure imagination. The technology for exploring these underwater ruins is advancing rapidly. Remotely operated vehicles, ROVs, can now descend to depths that were previously inaccessible, equipped with high-resolution cameras and sonar mapping systems that can create detailed three-dimensional models of submerged structures. Satellite imagery can detect underwater features from space, and new techniques in marine archaeology are making it possible to excavate sites under hundreds of feet of water. Each new discovery raises more questions than it answers. If these underwater ruins are the remains of prehistoric civilizations, what caused their destruction? Was it gradual submersion due to rising seas, or sudden catastrophic events like earthquakes and tsunamis? What technologies did these ancient peoples possess, and what knowledge died with them beneath the waves? Perhaps most intriguingly, what might these discoveries tell us about the relationship between water and human civilization? Water has always been both life-giver and destroyer, the substance that makes settlements possible, but also the force that can erase them from history. The cities that lie beneath the waves remind us that our relationship with water is one of constant negotiation. We depend on it absolutely, yet it remains wild and unpredictable, capable of reclaiming anything we build along its shores. As climate change once again alters sea levels and weather patterns, the story of these sunken cities becomes more than just archaeological curiosity. It becomes a warning and a lesson. The ruins beneath the waves whisper of civilizations that thought themselves permanent, of cities that seemed destined to last forever, of human achievements that proved no match for the patient, persistent power of water. In every submerged temple, every underwater palace, every drowned harbor, we see reflections of our own vulnerability and our own impermanence. We see evidence that water has been both the cradle and the grave of human civilization, the medium in which our greatest achievements can be preserved or destroyed, depending on forces far greater than human will or human technology. The cities that disappeared into water remind us that we are not separate from the natural world, but part of it, subject to the same forces that shape coastlines and carve canyons. They remind us that water is not just a resource to be managed, but a power to be respected, a force that has shaped human destiny for thousands of years and will continue to do so for thousands more. The blood of the earth, water beneath, volcano deep beneath your feet. in chambers of molten rock that could melt steel in seconds. Something extraordinary is happening. Water, the same substance you drink, bathe in, and watch fall as rain, is orchestrating some of the most violent events on our planet. But this isn't the gentle water of mountain streams. This is water as Earth's secret conductor, controlling the fury of volcanoes with the precision of a master musician. Imagine standing near Mount Vesuvius on a quiet afternoon. The slopes are green, dotted with vineyards, peaceful as a postcard. But miles below, water is playing a deadly game of chemistry. As oceanic plates slide beneath continental ones, a process geologists call subduction, they carry something unexpected with them: water. Not pools or rivers, but water molecules trapped within the crystal structure of rocks, held prisoner for millions of years. As these water-rich rocks descend into Earth's furnace, something magical and terrifying occurs. The intense heat and pressure don't just boil the water away, they transform it into something far more powerful. The water lowers the melting point of the surrounding rock, like salt melting ice on a winter sidewalk, but in reverse. Suddenly, solid rock becomes liquid magma, and that magma wants to rise. Here's where water reveals its true power as Earth's blood. Without water, most volcanic eruptions simply wouldn't happen. The magma would remain solid, locked in place. But water changes everything. It creates what volcanologists call wet magma, a superheated cocktail that's lighter than the surrounding rock, and desperately wants to reach the surface. But water's role goes deeper than just creating magma. It also determines how violently a volcano will erupt. When water-rich magma rises toward the surface, it's like shaking a champagne bottle. The dissolved water wants to become steam, and as pressure decreases, it expands explosively. The more water in the magma, the more violent the eruption. This is why some volcanoes ooze lava gently, like honey from a jar, while others explode with the force of atomic bombs. Hawaiian volcanoes, fed by relatively dry magma from deep in the earth, create those magnificent fountains of fire we see in documentaries. But volcanoes like Mount St. Helens, fed by water-rich magma, can literally blow their tops off, sending ash columns 50,000 feet into the sky. The ancient Greeks thought Hephaestus, the god of fire, lived beneath volcanoes, but perhaps they had it backwards. Maybe it's not the god of fire who controls these mountains, but the goddess of water, conducting her violent symphony from the depths, turning solid rock into liquid fury with nothing more than 2 hydrogen atoms and 1 oxygen atom arranged in the perfect impossible way. And here's the strangest part. This process has been happening for billions of years, recycling water between Earth's surface and its deep interior. The water erupting from Yellowstone today might have once been part of an ancient ocean, pulled down into the Earth's belly, superheated, and now returning to see the sky again. It's a planetary circulatory system, with water as the blood that keeps our planet alive and angry and beautiful. So the next time you see footage of a volcanic eruption, remember, you're not just watching molten rock, you're watching water's hidden power, the same substance that fills your morning coffee cup, conducting Earth's most spectacular performances from far below. Why scientists still don't understand water? Here's something that might surprise you. Open any physics textbook, flip to the section on water, and you'll find something almost embarrassing. After centuries of scientific progress, after splitting atoms and mapping the human genome, after sending robots to Mars, we still can't fully explain why water behaves the way it does. It's like having a best friend whose personality remains completely mysterious, no matter how long you've known them. Water should be a gas at room temperature. According to everything we know about molecular behavior, H2O should behave like its chemical cousins: hydrogen sulfide, hydrogen cyanide, hydrogen telluride. These molecules are all gases at the temperatures where we live and breathe. But water? Water decided to break the rules, to stay liquid in the narrow temperature range where life can flourish, almost as if it knew we'd need it that way. The reason water confounds scientists lies in something called hydrogen bonding, a force that's neither fully chemical nor fully physical, but something in between, like a whisper that's somehow stronger than a shout. Each water molecule can form up to 4 hydrogen bonds with its neighbors, creating a constantly shifting network of connections that break and reform billions of times per second. It's like an eternal dance where partners keep changing, but the rhythm never stops per second. This dance gives water properties that shouldn't exist. It expands when it freezes, which is why ice floats, why water pipes burst in winter, and why life survived the last ice age. Most substances get denser as they cool, but water has a mind of its own. At 4 degrees Celsius, it reaches its maximum density, then starts expanding again as it approaches freezing. It's as if water knows that life needs liquid water beneath the ice, so it thoughtfully provides a protective layer. Then there's water's specific heat, its ability to absorb enormous amounts of energy without changing temperature dramatically. This is why coastal cities have milder climates than inland areas, why your body temperature stays relatively stable, why Earth's climate is habitable at all. Water is like a planetary thermostat, absorbing heat during the day and releasing it at night, moderating temperature swings that would otherwise make Earth uninhabitable. But perhaps most mysteriously, water seems to have memory. Not consciousness exactly, but a kind of molecular memory that scientists are only beginning to understand. The arrangement of hydrogen bonds in water can persist for incredibly brief moments, just picoseconds. But in those fleeting instants, water molecules appear to remember how they were arranged. Some researchers believe this might explain homeopathy, though most scientists remain skeptical. Others wonder if water's memory might be key to understanding how life began. Dr. Gerald Pollack, a bioengineer at the University of Washington, has spent decades studying what he calls the fourth phase of water, a gel-like state that forms near surfaces and seems to store information. His research suggests that water near cell membranes behaves differently than bulk water, organizing itself into liquid crystal structures that might be crucial for biological processes. Even water's ability to dissolve substances, something we take for granted, is scientifically bizarre. Water is called the universal solvent because it can dissolve more substances than any other liquid. But why? It comes back to those hydrogen bonds, creating pockets of partial positive and negative charges that can surround and separate ions and molecules like a molecular embrace. The more we study water, the more questions arise. Why does hot water freeze faster than cold water under certain conditions? A phenomenon called the Mpemba effect. Why can water be supercooled to temperatures well below freezing while remaining liquid? Why does water have such a high surface tension that insects can walk on it? Perhaps most humbling of all, we still don't fully understand how water moves through the narrow channels in our cells, or how it helps proteins fold into their proper shapes, or why it's essential for every known form of life. Water remains the familiar stranger, the substance we think we know but don't, the simple molecule that makes complexity possible. The consciousness theory. Is water a living network? What if water isn't just a substance but a medium for something far more profound? What if those hydrogen bonds we've been discussing aren't just chemical attractions, but part of a vast, interconnected network that might be aware? This isn't science fiction, though it sounds like it should be. This is a serious question being asked by serious scientists, mystics and philosophers around the world. From the laboratories of quantum physicists to the meditation halls of Zen monasteries, people are wondering whether water might possess a form of consciousness that we're only beginning to glimpse. The idea isn't entirely new. Indigenous cultures have long spoken of water as a living entity, something to be respected and consulted, rather than simply consumed. Aboriginal Australians tell stories of water spirits that inhabit every stream and billabong. Hindu traditions speak of the Ganges, not just as a river, but as a goddess whose waters carry prayers and consciousness across the subcontinent. But now, quantum mechanics is providing a scientific framework for ideas that once belonged purely to the realm of mysticism. Dr. Stuart Hameroff, an anesthesiologist and consciousness researcher at the University of Arizona, proposes that consciousness might emerge from quantum processes in cellular structures called microtubules. These structures are filled with water. The theory goes like this. Consciousness isn't produced by the brain alone, but emerges from quantum coherence in the water-filled microtubules inside neurons. These tiny tubes, just nanometers wide, are like quantum computers running on water's unique properties. The hydrogen bonds in water create a network capable of storing and processing information at the quantum level. If this sounds far-fetched, consider what we already know about water's information-carrying capacity. Japanese researcher Dr. Masaru Emoto claimed that water crystals change shape based on the emotional content of words spoken to them. While his methodology has been criticized, the underlying idea that water can store and respond to information isn't entirely impossible given what we know about water's molecular structure. Water's hydrogen bond network is constantly forming and breaking, creating patterns that last for picoseconds, but might carry information during their brief existence. Some researchers compare it to the neural networks in our brains, where information is stored not in individual neurons, but in the patterns of connections between them. Buddhist monks have long practiced water meditation, sitting beside streams and lakes, claiming to commune with the consciousness they believe flows through all water. Thich Nhat Hanh, the Vietnamese Zen master, wrote about the interbeing of water, how the water in a cloud, a river, and our bodies are all part of one continuous conscious flow. From a purely physical perspective, water does behave as if it's sharing information across vast distances. When you disturb water in one part of a container, waves ripple across the entire surface, almost instantaneously. At the molecular level, changes in one part of a water network can influence the hydrogen bonding patterns throughout the entire structure. Some scientists propose that Earth's water cycle itself might function as a kind of planetary nervous system. Water evaporates from the oceans, carrying information in its molecular structure. It forms clouds, falls as rain, flows through rivers, and returns to the sea, potentially carrying and distributing information across the entire planet. This isn't proven science. It's at the very edge of what we can measure and understand. But consider this. Consciousness remains one of the deepest mysteries in science. We don't know how awareness arises from matter, how subjective experience emerges from objective reality. We know consciousness requires water. Every known conscious being is largely made of it. Perhaps consciousness and water are more intertwined than we've ever imagined. Whether water is truly conscious or not, there's something undeniably profound about this substance that connects all life. The water in your body has been part of clouds, rivers, oceans, and other living beings. It's a continuous planetary circulation that links you to every raindrop, every snowflake, every tear that has ever fallen. Tonight, as you drift towards sleep, perhaps you can sense it, the water within you, humming with possibilities, carrying messages between your cells, participating in the vast, fluid conversation that might be consciousness itself. Messages in the snow, how water remembers geometry. Every snowflake is a love letter from mathematics to the universe, written in a language of perfect angles and crystalline symmetry. But here's what makes snowflakes truly mysterious. They all obey the same basic rules, yet each one is unique. How does water, falling from the sky, know to create such perfect geometry? What invisible hand guides these frozen messages into existence? When water vapor in a cloud begins to freeze around a tiny particle of dust or pollen, something magical happens. The water molecules don't just freeze randomly, they arrange themselves according to the fundamental structure of ice, which is hexagonal. This six-sided symmetry isn't arbitrary. It's the most efficient way for water molecules to bond with each other in a solid state, like dancers finding their perfect formation. But here's where it gets strange. As that initial ice crystal falls through different layers of atmosphere, encountering varying temperatures and humidity levels, it grows, and somehow, mysteriously, all 6 arms of the snowflake grow in almost perfect synchronization. If one arm develops a delicate branch, the other 5 arms develop similar branches at similar locations. It's as if the 6 arms are communicating with each other, sharing information about what shape they should become. Scientists call this phenomenon symmetric growth. But that name doesn't capture the profound mystery it represents. How does the left arm of a snowflake know what the right arm is doing? The arms aren't connected by any obvious mechanism. They're separated by distances vast in molecular terms. Yet they coordinate their growth with precision that would make synchronized swimmers jealous. Dr. Kenneth Librecht, a physicist at Caltech, who has devoted his career to understanding snowflakes, describes it as one of the most beautiful unsolved problems in physics. The snowflake arms are responding to the same atmospheric conditions as they fall, but the level of coordination they achieve suggests something more subtle at work, perhaps quantum coherence, or some form of information sharing through the snowflake's internal structure. Each snowflake becomes a frozen record of its journey through the clouds. The branching patterns, the delicate lacework, the intricate details, all of these features tell the story of the specific atmospheric conditions the snowflake encountered. Temperature changes are recorded as changes in crystal structure. Humidity variations show up as different types of growth patterns. A snowflake is essentially a frozen diary of its trip from cloud to ground. But water's geometric memory goes far deeper than snowflakes. When water freezes, it expands in a precise pattern, creating a crystal lattice with exactly the right structure to make ice less dense than liquid water. This isn't just convenient for life, it's essential. If ice were denser than water, it would sink, and bodies of water would freeze from the bottom up, killing most aquatic life during winter. Even in its liquid state, water seems to remember geometry. The hydrogen bond network in liquid water constantly shifts between different structural arrangements, some more ordered, some more chaotic. Researchers have found that water can maintain temporary structural memory of these arrangements for brief moments, like a jazz musician remembering the chord progression even as the music flows forward. This geometric memory might explain some of water's most unusual properties. The angles between hydrogen bonds in water are close to the tetrahedral angle found in many crystal structures, which might be why water is such an excellent solvent and why it interacts so readily with biological molecules. In traditional Chinese philosophy, water is associated with the concept of wu wei, effortless action, going with the flow while maintaining perfect form. Watching snowflakes form, it's easy to see why. Water doesn't seem to struggle to create these perfect geometric patterns. It simply follows its nature, allowing the mathematics embedded in its molecular structure to express itself. Sacred geometry enthusiasts point out that snowflakes contain many of the patterns found in mandalas, Islamic art, and Gothic cathedral windows, hexagons, triangles, and star patterns that humans have found beautiful and meaningful across cultures. Perhaps we're drawn to these patterns because they echo the geometric principles that water has been using to create beauty for billions of years. As you watch snow fall outside your window, or remember the last time you caught snowflakes on your sleeve, consider the profound mystery you're witnessing. Each flake is a unique geometric message, a crystalline poem written by water in the language of mathematical perfection. Water isn't just following physical laws, it's creating art, writing messages in ice that speak to something deep in our pattern-seeking minds. The shape of reality. Water and sacred geometry. There's something almost mystical about the way water moves. The perfect spiral of water going down a drain, the hexagonal patterns in snowflakes, the golden ratio spirals in ocean waves. Is water simply following the laws of physics, or is it revealing something deeper about the mathematical structure of reality itself? Ancient philosophers believed that geometry was the language God used to write the universe. Plato taught that behind all physical reality lay perfect geometric forms, the circle, the triangle, the sphere. Modern physics has proven him remarkably prescient. From the hexagonal structure of benzene rings to the spiral arms of galaxies, the universe appears to be constructed according to geometric principles that water seems to understand intuitively. Consider the simple act of water flowing around a stone in a stream. The flow lines that form aren't random. They follow precise mathematical curves called hyperbolic functions. Water naturally creates what mathematicians call minimal surfaces, shapes that use the least energy possible while accommodating the constraints of the environment. It's as if water is constantly solving complex calculus problems without effort. When a droplet falls into still water, it creates a perfect circle of ripples that expand outward at precisely calculated intervals. The spacing between these ripples follows a mathematical relationship that depends on surface tension, gravity, and the fluid properties of water. Yet water doesn't need to consult an equation, it simply creates perfect geometry. The golden ratio, approximately 1.618, a number that appears throughout nature and art, shows up repeatedly in water's behavior. Ocean waves often display this ratio in the relationship between their height and wavelength. The spirals in whirlpools and the branching patterns of river deltas frequently approximate golden ratio proportions. Even the way water droplets merge follows geometric principles related to this ancient mathematical constant. Dr. Victor Scharberger, an Austrian forester and naturalist, spent his life studying water's natural flow patterns. He noticed that healthy streams create what he called egg-shaped flow patterns, three-dimensional curves that maximize energy efficiency while minimizing turbulence. These curves appear throughout nature, in the shape of seeds, the flow of blood through arteries, even in the orbital patterns of planets. Schauberger believed that water was showing us the fundamental templates for natural design. He observed that when water flows in its natural curved patterns, it becomes more energized, more alive. Straight channels and right-angle turns, by contrast, seemed to deaden water, reducing its vitality and its ability to support life. Indigenous cultures worldwide have recognized water's geometric wisdom. Aboriginal Australian songlines often follow the curved paths of rivers, recognizing these waterways as embodiments of sacred geometry. Hindu temples are designed around water features that create specific geometric patterns, believed to harmonize the energy of the space. Even at the molecular level, water reveals geometric mysteries. The angle between the two hydrogen atoms in a water molecule, 104.5 degrees, is close to the tetrahedral angle found in many crystal structures and biological molecules. This angle gives water its unique properties, but it also connects water to the geometric patterns that appear throughout organic chemistry. The spiral, perhaps the most fundamental shape in nature, appears wherever water is present. DNA spirals in a water-based medium. Hurricanes spiral as they organize water and air. Even our inner ears use spiral structures filled with fluid to detect balance and motion. It's as if the spiral is water's signature shape. the geometric pattern it uses to organize energy and information. Buckminster Fuller, the visionary architect and mathematician, believed that water was nature's way of teaching us about efficient design. He studied the geodesic patterns that appear in soap bubbles, the minimal surface geometry that water naturally creates. His famous geodesic domes were inspired partly by these water-based geometric insights. Perhaps most mysteriously, water seems to know when to break symmetry and when to maintain it. Snowflakes maintain perfect six-fold symmetry, but river meanders break symmetry in predictable ways that maximize energy dissipation. Waves maintain symmetry as they propagate across the ocean, but break that symmetry in complex, beautiful patterns when they crash against the shore. Is water following geometric laws, or is geometry emerging from water's fundamental nature? As you listen to rain against your window or watch steam rise from your tea, consider the possibility that you're witnessing the universe revealing its mathematical secrets through the most familiar, yet mysterious substance on Earth, the ocean that lives inside you. Right now, as you listen to these words, you're carrying an ancient ocean within your body. The salt water flowing through your veins has almost exactly the same mineral composition as seawater. Not modern seawater, but the primordial ocean that existed when life first crawled out of the sea hundreds of millions of years ago. You are, quite literally, a walking, talking piece of that ancient ocean, wrapped in skin and given consciousness. This isn't poetic metaphor, it's biochemical fact. Your blood plasma contains sodium, potassium, chloride, and magnesium, in proportions that mirror seawater so closely that early researchers wondered if our ancestors simply never left the ocean at all, but instead carried it with them as they evolved. The French physiologist René Quinton was so struck by this similarity that in the early 1900s he successfully treated patients by injecting them with diluted seawater, believing that their bodies would recognize and welcome this familiar fluid. But the ocean inside you is more than just a fossil remnant of evolutionary history. It's an active, dynamic system that mirrors the behavior of Earth's oceans in remarkable ways. Your body temperature is regulated by the same principles that govern ocean currents, warm currents carrying heat from your core to your extremities, cool currents returning to be rewarmed. Your kidneys function like oceanic filtration systems, removing waste while carefully maintaining the precise salt balance that your cells need to survive. Even more mysteriously, the tides that pull on Earth's oceans may be pulling on you as well. Some researchers have found correlations between lunar cycles and biological processes, not just the obvious ones like women's menstrual cycles, but subtler rhythms in blood pressure, immune function, and even wound healing. The moon that moves billions of tons of seawater twice daily might also be gently tugging at the ocean within your body. Consider the mathematics of this internal ocean. An average human body contains about 42 liters of water, roughly 11 gallons. This water isn't static. It's in constant motion, circulating through your cardiovascular system, flowing between cells, carrying nutrients and messages throughout your body. Your heart beats about 100,000 times per day, circulating this internal ocean through thousands of miles of blood vessels. In a single day, your kidneys filter about 180 liters of fluid, carefully maintaining the composition of your internal sea. But perhaps most remarkably, this ocean inside you is conscious. Not metaphorically, but literally. Consciousness appears to emerge from the water-based electrochemical processes in your brain. Your thoughts, your memories, your sense of self, all arise from patterns of electrical activity flowing through the aqueous medium of your nervous system. When you remember the taste of salt air or the sound of waves, you're using water to think about water, ocean, remembering ocean. The tears you cry when moved by beauty or sadness have the same salt content as that ancient sea. Ancient cultures recognize this connection. The word tears shares linguistic roots with words for sea and flow in many languages. When you weep, you're literally returning part of your internal ocean to the external world, releasing a piece of the primordial sea that lives within you. Your body's relationship with water goes even deeper than circulation and chemistry. The water in your cells isn't just a passive medium, it's an active participant in biological processes. The structured water near cell membranes helps proteins fold correctly, enables enzymes to function, and may even play a role in storing biological information. Some researchers believe that the water in our cells forms liquid crystal structures that are essential for life itself. Even your sense of balance depends on water. Your inner ears contain fluid-filled chambers called the semicircular canals, where the movement of water-like endolymph tells your brain which way is up. When you feel dizzy, you're experiencing a disruption in these internal water systems. Motion sickness occurs when your internal fluid systems disagree with what your eyes are seeing. The ocean inside you becomes turbulent. As you age, you gradually lose water content. Infants are about 75% water, while elderly adults may be only 50% water. Some gerontologists believe that aging is in part a process of slowly returning to the land, gradually losing our connection to the oceanic origins of life. But even in old age, even at the moment of death, we remain primarily water, primarily ocean. Tonight, as you settle into sleep, listen to the sound of your heartbeat. Feel the pulse in your wrists. That's your internal ocean circulating. The ancient sea that you carry within you, connecting you to every living thing that has ever depended on water. You are not separate from the ocean. You are the ocean, temporarily organized into the beautiful, complex, conscious form that is you. Water on the moon. And the cosmic water map. Here's something that might surprise you as you look up at the moon tonight. There's water up there. Not just traces, not just theoretical possibilities, but actual water ice, billions of tons of it, hiding in the permanently shadowed craters near the lunar poles. This discovery has revolutionized our understanding, not just of the moon, but of water's cosmic journey throughout the universe. For decades, we thought the moon was bone dry, a sterile rock baked by solar radiation and scoured by the solar wind. The Apollo astronauts found no signs of water in their lunar samples, but in 2009, NASA deliberately crashed a spacecraft called L-Cross into a shadowed crater near the moon's south pole, and the resulting plume of debris contained something unexpected: water vapor. Lots of it. The moon wasn't dry after all, it was just very good at hiding its water. But how did water get to the moon? The leading theory sounds like science fiction. It was delivered by comets and asteroids over billions of years. These icy messengers from the outer solar system bombarded the moon during what astronomers call the Late Heavy Bombardment, a period about 4 billion years ago, when the inner solar system was pelted with debris left over from the formation of the planets. Some of these cosmic snowballs crashed into permanently shadowed regions near the moon's poles, where temperatures remain below -200 degrees Celsius, cold enough to preserve water ice for billions of years. These lunar cold traps became archives of ancient water, storing samples of the primordial ice that helped build the solar system. But the moon is just one stop on water's cosmic journey. Mars has water ice at its poles, and possibly liquid water beneath its surface. Europa, one of Jupiter's moons, likely contains more water than all of Earth's oceans combined, hidden beneath a shell of ice. Enceladus, a tiny moon of Saturn, shoots geysers of liquid water into space from an underground ocean that might harbor life. Even more remarkably, astronomers are finding water throughout the galaxy. They've detected water vapor in the atmospheres of distant planets, in the swirling disks of dust and gas around newborn stars, even in the empty space between stars. Water appears to be one of the most common molecules in the universe, formed whenever hydrogen and oxygen come together under the right conditions. This cosmic abundance of water suggests something profound about our place in the universe. The water in your body, the water in that glass beside you, has been on an incredible journey. It may have formed in the heart of a dying star, been scattered into space by stellar winds, incorporated into comets in the outer reaches of our solar system, and eventually delivered to Earth by cosmic impacts billions of years ago. The water cycle we learn about in school, evaporation, condensation, precipitation, is just the local version of a much grander cosmic water cycle. Water evaporates from planetary surfaces, gets stripped away by stellar winds, condenses in the cold depths of space, and eventually gets recycled into new worlds orbiting distant stars. The universe has been playing this game of cosmic water cycling for over 13 billion years. Some scientists believe that water's cosmic ubiquity might be key to understanding life's potential throughout the universe. If water is common, and if water is essential for life as we know it, then life itself might be more common than we ever imagined. Every time we discover water on another world, whether it's subsurface oceans on icy moons or water vapor in the atmospheres of distant planets, we're mapping the potential homes for life in our galaxy. The James Webb Space Telescope has revolutionized our ability to detect water in distant worlds. It can analyze the light passing through an exoplanet's atmosphere and identify the spectral signature of water vapor. Already it's found water in the atmospheres of dozens of planets orbiting other stars, painting a picture of a universe where water is not rare and precious, but common and widespread. Perhaps most intriguingly, some astronomers are beginning to think that water might have played a role in the formation of the first stars and galaxies. Water molecules can form in the cold, dense clouds of gas and dust where stars are born, and they might help those clouds collapse and condense into stellar nurseries. If this is true, then water isn't just essential for life, it might be essential for the very structure of the universe itself. As you drift towards sleep tonight, consider the cosmic heritage of the water within you. Every molecule of H2O in your body has traveled across space and time to be here, now, as part of you. You are made of stardust and comet ice, of water that has seen the birth of stars and the formation of worlds. You are a temporary arrangement of cosmic water, briefly conscious, momentarily aware of its own incredible journey through the universe, the fourth phase of water, and the secret scientists found. We've always been taught that water exists in three phases: solid ice, liquid water, and gaseous steam. But what if there's a fourth phase, hiding in plain sight, with properties so strange that it challenges everything we thought we knew about this familiar substance? What if this fourth phase of water is not just scientifically curious, but essential to life itself? Dr. Gerald Pollack at the University of Washington has spent over a decade studying what he calls exclusion zone water, or easy water, a gel-like phase of water that forms near hydrophilic water-loving surfaces. This isn't theoretical physics. It's water you can see under a microscope, water that behaves like neither liquid nor solid, but something entirely different. When water comes into contact with certain surfaces, like the proteins in your cell membranes, or even simple materials like Nafion plastic, something remarkable happens. The water molecules near the surface begin to organize themselves into sheets, creating a gel-like layer that can extend hundreds of thousands of molecules away from the surface. This isn't just water clinging to a surface, it's water transforming into a new phase of matter. This fourth phase water has properties that seem almost magical. It excludes particles and solutes, hence the name exclusion zone. If you put bacteria or tiny plastic spheres into water near these surfaces, they get pushed away, as if the water near the surface has become selectively permeable. The easy water is more viscous than normal water, more structured, and surprisingly, it holds electrical charge. Here's where it gets truly strange. This fourth phase water appears to store energy. When light hits easy water, it grows larger and more organized. Infrared radiation, the same energy that comes from sunlight and your own body heat, seems to power the formation of this structured water. It's as if this fourth phase of water is a kind of biological battery, powered by light and capable of storing information in its organized structure. Pollack believes this fourth phase of water might be crucial for biological processes. Consider your cells. They're filled with water, but not just any water. The water inside your cells is in constant contact with proteins, DNA, and cell membranes. If this cellular water is organizing itself into fourth phase structures, it might explain some of biology's biggest mysteries. How do proteins fold so quickly and accurately? How do enzymes work with such precision? How do cells maintain their organization against the constant tendency toward chaos? The answer might lie in the structured water that surrounds and supports these biological molecules. Easy water might provide the organized environment that life needs to function. But the implications go even further. If cellular water can store energy and information in its structure, it might help explain how biological systems maintain their complexity. Living things seem to violate the second law of thermodynamics. They create order from chaos, build complex structures from simple components. But if the water in our cells is constantly organizing itself using environmental energy, then life might not be violating physical laws at all. It might be using water's fourth phase as a kind of biological engine. Some researchers are beginning to wonder if this structured water might play a role in consciousness itself. The brain is about 78% water, and that water is in constant contact with neurons, synapses, and support cells. If the water in our brains is organizing itself into fourth phase structures, storing and processing information in ways we don't yet understand, it might help explain how consciousness emerges from neural activity. Traditional Chinese medicine has long spoken of structured water and its importance for health. Practitioners believe that healthy bodies contain more organized structured water, while illness is associated with less organized cellular water. From the perspective of fourth phase water research, these ancient insights might have been more accurate than modern medicine realized. Even more intriguingly, some researchers are investigating whether fourth phase water might explain homeopathy, the controversial practice of treating illness with highly diluted substances. If water can maintain structural organization that stores information, then perhaps highly diluted solutions really do retain some memory of the original substance, encoded in the water's fourth phase structure. The technology applications are staggering. If we can learn to control and manipulate fourth phase water, we might be able to create new types of batteries, more efficient solar cells, even biological computers that use water's information storage capacity. Some researchers are already experimenting with devices that harvest energy from the formation of easy water. As you settle into sleep tonight, consider the possibility that the water in your body isn't just a passive medium, but an active participant in the process of being alive. The structured water in your cells might be storing energy from your environment, organizing itself to support the complex chemistry of life, perhaps even participating in the mysterious process of consciousness itself. You are not just made of water. You might be made of water's most extraordinary phase, a living gel that bridges the gap between simple chemistry and the miracle of life. Why water can burn, the forgotten energy source. Here's something that sounds impossible. Water can burn. Not metaphorically, not in some poetic sense, but literally. Under the right conditions, water can release more energy than gasoline, more power than coal, more explosive force than dynamite. The same substance you drink for hydration contains enough locked-away energy to power cities, fuel rockets, and revolutionize our relationship with the planet. So why aren't we using it? The secret lies in water's most abundant component, hydrogen. Every water molecule contains 2 hydrogen atoms, and hydrogen is the most energy-dense fuel in the universe by weight. When hydrogen burns, combining with oxygen, it releases tremendous energy and produces only one byproduct, water vapor. It's the cleanest fuel imaginable, the universe's own renewable energy source. Rocket scientists have known this for decades. The space shuttle's main engines burned hydrogen and oxygen, essentially burning water's components to escape Earth's gravity. The chemical reaction 2H2 plus O2 equals 2H2O plus energy is the same reaction that powers the Sun and every other star in the universe. When we split water apart and burn its hydrogen, we're briefly recreating stellar fire here on Earth. But here's the fascinating part. We can also make water burn directly, without separating it first. Under intense heat and pressure, water molecules can break apart and recombine in ways that release energy. This process, called thermolysis, can turn ordinary water into a plasma that burns hotter than any chemical flame. Some researchers are investigating whether focused lasers or electromagnetic fields could trigger this process efficiently enough to use water as a direct fuel source. The technology to split water into hydrogen and oxygen, called electrolysis, has existed for over 2 centuries. Pass an electric current through water, and it separates into its component gases. The hydrogen can then be stored and burned when energy is needed, recombining with oxygen to form water again. It's a perfect closed loop. Water to hydrogen to energy to water again, with no pollution, no carbon emissions, no toxic waste. Stanley Meyer, an American inventor, claimed in the 1990s that he had developed a water fuel cell that could split water using very little energy, essentially running a car on water. His claims were controversial and never independently verified, but they inspired a generation of researchers to investigate more efficient ways to extract energy from water. While Meyer's specific claims remain disputed, the underlying science, that water contains enormous amounts of accessible energy, is absolutely real. The challenge isn't that water can't be used as fuel, it's that extracting the energy efficiently requires more energy than you get back. Traditional electrolysis uses more electricity to split water than you can recover by burning the resulting hydrogen. It's like trying to lift yourself by your own bootstraps. Thermodynamically challenging. But researchers around the world are finding clever ways around this limitation. Some are using catalysts that make electrolysis more efficient. Others are investigating biological processes. Certain algae and bacteria can split water using sunlight, essentially doing photosynthesis in reverse. Still others are exploring quantum effects that might allow water splitting at much lower energy costs. Perhaps most intriguingly, some scientists are investigating whether water's 4th phase, that mysterious easy water we discussed earlier, might provide a more efficient pathway to hydrogen production. If structured water already contains stored energy from environmental sources, it might be possible to extract hydrogen from easy water with much less additional energy input. The potential is staggering. The oceans contain enough hydrogen to power human civilization for millions of years. Every glass of water contains enough energy, if we could extract it efficiently, to power a small city for hours. We're literally surrounded by fuel, sitting on top of the greatest energy reserve in the solar system, while arguing about depleting fossil fuel reserves. Some visionaries imagine a hydrogen economy where water becomes our primary fuel source. Homes would have water-splitting systems powered by solar panels, producing hydrogen during the day and burning it for heat and electricity at night. Cars would run on hydrogen fuel cells, emitting only water vapor. Ships could split seawater as they travel, creating their own fuel from the ocean they sail on. The irony is profound. We worry about energy scarcity while swimming in an ocean of potential fuel. We fight wars over oil while water covers 70% of our planet's surface. We pollute the atmosphere with carbon while the cleanest fuel in the universe falls from the sky as rain. But perhaps there's a deeper lesson here about our relationship with water. For too long we've seen water as separate from energy, as separate from technology, as separate from the solutions to our global challenges. But water isn't separate from anything. It's connected to everything. The energy crisis, the climate crisis, the water crisis. They're all the same crisis, all expressions of our failure to understand the true nature of this miraculous substance. As you listen to the rain outside your window, or hear water running through pipes in your walls, remember, you're listening to potential energy, to a fuel source that could power the world cleanly and sustainably. Every drop contains enough energy to lift itself into the sky, to carve canyons through solid rock, to sustain all life on Earth. We just need to learn how to listen to what water has been trying to tell us all along. The underwater creatures that shouldn't exist. In the deepest parts of our oceans, where sunlight has never touched, and the pressure would crush a human body in milliseconds, something impossible is happening. Life is thriving, not just surviving, but flourishing in conditions so extreme that they shouldn't allow complex organisms to exist. These creatures live in water so deep and hostile that it challenges everything we thought we knew about the limits of life. Imagine descending into the abyss, past the continental shelf where familiar fish swim, past the midnight zone where bioluminescent jellies drift like living stars, deeper still into the Hadal zone, named after Hades, the underworld of Greek mythology. Here, 7 miles below the surface, the pressure reaches over 1,000 times that at sea level. It's like having the weight of 50 jumbo jets pressing down on every square inch of your body. At these depths, water itself becomes strange. The immense pressure compresses it into a denser form, and the near-freezing temperatures slow molecular motion to a crawl. The water is thick, almost syrupy, and completely devoid of oxygen. It should be a sterile wasteland, a liquid desert where nothing can live. Yet in 2019, researchers exploring the deepest part of the Pacific Ocean, the Challenger Deep in the Mariana Trench, discovered something extraordinary. Swimming at depths of over 35,000 feet, they found snailfish, amphipods, and other complex creatures going about their daily lives, as if 7 miles of crushing ocean above them was perfectly normal. How do these creatures survive? The answer lies in water's most mysterious properties, and life's incredible ability to adapt to them. These deep-sea organisms have evolved proteins that remain stable under extreme pressure, cellular membranes that don't collapse, and metabolisms that function in conditions that would instantly kill surface dwellers. But perhaps most remarkably, these creatures use the properties of high-pressure water itself as tools for survival. The dense, compressed water at these depths conducts sound and vibration differently than surface water. Many deep-sea creatures have evolved incredibly sensitive sensory systems that can detect the tiniest movements in this dense medium. They can sense prey or predators from vast distances by feeling the subtle pressure waves that ripple through the compressed water. Some deep-sea fish have developed swim bladders filled with specialized fats instead of gas, because at these depths, gas-filled organs would collapse instantly. Others have eliminated swim bladders entirely, their bodies becoming essentially liquid themselves, matching the density of the water around them. They've become one with the abyss, their bodies indistinguishable from the crushing medium they inhabit. Near underwater volcanic vents, where superheated water rich in chemicals erupts from the seafloor, entire ecosystems thrive without any connection to surface photosynthesis. Giant tube worms, ghostly white crabs, and bizarre fish cluster around these underwater oases, feeding on bacteria that derive energy from the chemical-rich hot water. These communities represent an entirely different form of life, one based not on sunlight, but on the chemical energy locked within water itself. The giant isopods that crawl across the deep ocean floor look like enormous pill bugs, sometimes growing larger than footballs. They move slowly through the dense water, their segmented bodies perfectly adapted to the crushing environment. Some can survive for years without food, slowing their metabolism to nearly nothing, waiting patiently in the eternal darkness for a meal to drift down from the surface. Bioluminescence becomes even more magical at these depths. With no sunlight to interfere, creatures create their own light shows in the abyss. Deep-sea anglerfish dangle glowing lures in front of their mouths, using bioluminescent bacteria to create living fishing rods. The light interacts strangely with the dense, high-pressure water, creating eerie patterns and colors that exist nowhere else on Earth. But perhaps the most mind-bending discovery is that some of these deep-sea creatures appear to be virtually immortal. The extreme conditions that should kill them seem instead to preserve them. The cold temperatures, high pressure, and lack of oxygen create an environment where aging processes slow to a crawl. Some deep-sea clams and sponges may be thousands of years old, ancient witnesses to the long, slow time of the abyss. These discoveries are revolutionizing our understanding of life's possibilities. If complex organisms can thrive in the crushing depths of Earth's oceans, what does that say about the potential for life in the underground oceans of Europa or Enceladus? If life can flourish in water under conditions more extreme than anything on most planets, then the universe's potential for harboring life might be far greater than we ever imagined. The creatures of the abyss are living proof that water's life-supporting properties extend far beyond the narrow range of conditions we experience at the surface. They've adapted not just to survive in extreme water, but to thrive in it, to use its strange properties as advantages rather than obstacles. As you float in the shallows of sleep tonight, carried by the gentle currents of your dreams, remember the profound mystery swimming in the deepest waters of our world. 7 miles below the surface, in water so compressed and cold and dark that it seems like another planet entirely. Life continues its ancient dance with water, proving once again that this simple molecule contains depths we're only beginning to explore. Is Earth a water planet, or just a vessel? Here's a question that might keep you awake tonight, staring at the ceiling and wondering about the nature of our blue marble home. Is Earth fundamentally a water planet that happens to have some rock in it, or is it a rocky planet that happened to collect some water? The answer to this seemingly simple question reveals something profound about our place in the cosmos and the true nature of the world beneath our feet. When astronauts first saw Earth from space, they didn't call it the blue planet because of its atmosphere. They called it blue because of its water. From the cosmic perspective, Earth is defined by its oceans. 71% of the surface is covered by water, and if you could smooth out all the mountains and valleys, the entire planet would be covered by an ocean over 2 miles deep. But here's what makes this even more remarkable. Earth shouldn't have this much water. According to the most widely accepted models of planetary formation, worlds that form as close to their star as Earth does should be dry, baked clean of volatile substances like water by the intense heat of the young sun. Venus and Mercury, our closer neighbors, are indeed bone dry. Mars, farther out, has only traces of water remaining. So where did Earth's vast oceans come from? The leading theory sounds like something from mythology. Our water came from space, delivered by an army of icy comets during a period called the Late Heavy Bombardment, roughly 4 billion years ago. These cosmic snowballs, some as large as small cities, crashed into the young Earth, vaporizing on impact, and gradually filling the basins that would become our oceans. If this theory is correct, then Earth didn't form with water. It was gifted water by the cosmos. But recent discoveries are complicating this beautiful story. Scientists analyzing ancient zircon crystals, some of the oldest materials on Earth, have found evidence that liquid water existed on our planet's surface as early as 4.4 billion years ago, just 150 million years after Earth formed. This is much earlier than the Late Heavy Bombardment, suggesting that Earth might have had water from the very beginning. Perhaps even more intriguingly, researchers studying the deep Earth have discovered that our planet's interior contains vast amounts of water, locked away in the crystal structure of minerals hundreds of miles below the surface. The transition zone between the upper and lower mantle, a region between 410 and 660 kilometers deep, may contain more water than all the surface oceans combined. This isn't liquid water, but water molecules incorporated into the crystal lattice of minerals, like ringwoodite and wadsleyite. This deep water reservoir suggests something extraordinary. Earth might be fundamentally a water world, not just on the surface but throughout its entire structure. The water we see in our oceans, rivers and clouds might be just the small fraction that has managed to reach the surface. The vast majority of Earth's water might be hidden deep within the planet, cycling slowly between the surface and the interior over geological time. Consider the implications. If Earth contains more water in its deep interior than on its surface, then our planet is even more dominated by water than we realized. We're not living on the surface of a rocky world with some water on top. We're living on the thin, exposed skin of a water world, most of whose water remains hidden from view. This hidden water plays a crucial role in plate tectonics, volcanic activity, and the long-term evolution of our planet. Water in the deep Earth lubricates the movement of tectonic plates, influences the formation of magma, and helps regulate the planet's internal temperature. Without this deep water, Earth might be a geologically dead world like Mars, unable to maintain the active surface processes that make our planet habitable. But there's an even more radical possibility, being explored by some researchers. What if water isn't just a component of Earth, but the organizing principle that shaped our planet from the beginning? What if the presence of water determined not just Earth's climate and geology, but its fundamental structure and evolution? This idea draws on water's unique properties as a universal solvent, and its ability to facilitate chemical reactions. In the early Earth, water might have acted as a kind of planetary catalyst, enabling the chemical processes that differentiated our planet into core, mantle, and crust. Water's presence might have determined which minerals formed, how they were distributed, and ultimately, the very architecture of our world. Some scientists even propose that Earth's magnetic field, generated by the motion of liquid iron in the outer core, might be influenced by water content in the deep Earth. If water helps control the flow patterns in the core, then our planet's magnetic shield, which protects us from harmful solar radiation, might depend on the vast reservoir of water hidden in Earth's interior. From this perspective, Earth isn't a rocky planet with water. It's a water planet temporarily organized into rock, atmosphere, and ocean. We're not visitors on a world that happens to have water. We're expressions of water's creative potential, conscious arrangements of H2O temporarily aware of their own watery nature. As you drift toward sleep, consider the vast ocean of water beneath your feet. Not just the familiar ocean of waves and tides, but the hidden ocean in the deep Earth. The water locked in minerals hundreds of miles down, cycling slowly through the planet's interior, on timescales longer than the existence of complex life. You're resting on the surface of a water world, supported by water, made of water, dreaming water dreams in a cosmos, where water shapes not just life, but the very worlds where life can exist. What if water is not from this world? As we reach the end of our journey through water's mysteries, we arrive at the most profound question of all, one that challenges everything we think we know about this familiar substance. What if water isn't originally from Earth? What if this molecule that defines our planet, shapes our bodies, and makes consciousness possible, is actually a visitor from somewhere else in the universe? This isn't science fiction speculation. It's a serious hypothesis being explored by astrobiologists, cosmologists, and planetary scientists around the world. The evidence is scattered across multiple fields of study, but when assembled, it paints a picture that's both humbling and magnificent. Water might be older than our solar system, more traveled than any human explorer, and more alien than we ever imagined. Consider the isotopic signature of Earth's water, the ratio of regular hydrogen to heavy hydrogen, deuterium, in our oceans. This ratio is like a fingerprint, revealing the cosmic history of water molecules. When scientists compare Earth's water signature to that of asteroids, comets, and even the Sun, they find something surprising. Earth's water doesn't match the local solar system average. Instead, it bears a stronger resemblance to water found in the interstellar medium, the space between stars. This suggests that much of Earth's water might be older than the Sun itself, formed in the cold, dark regions between stars, before our solar system even existed. These ancient water molecules would have been incorporated into the collapsing cloud of gas and dust that eventually became our Sun and planets. In other words, the water in your body might be older than the world you're living on. But the story gets even stranger. Recent studies of meteorites, particularly a class called carbonaceous chondrites, have revealed that they contain water with isotopic signatures that don't match Earth's oceans perfectly. Some match closely, others don't match at all. This suggests that Earth's water came from multiple sources, a cosmic mixture of different water reservoirs from different parts of the early solar system. Some researchers propose that Earth's water arrived in waves. The first wave might have come from asteroids formed closer to the Sun, delivering water with one isotopic signature. Later waves might have come from comets formed in the outer solar system, bringing water with different characteristics. Each cosmic delivery added to Earth's growing water inventory, creating the complex mixture we find in our oceans today. But here's where it gets truly mind-bending. If water from different parts of the solar system has different properties, different isotopic signatures, different histories, then the water in your body right now might be a mixture of substances from across the cosmos. Some water molecules in your blood might have formed near Jupiter's orbit. Others might have crystallized in the cold depths beyond Pluto. Still others might be interstellar vagabonds, older than the solar system itself. Dr. Cecilia Ceccarelli, an astrochemist at the University of Grenoble, has spent her career studying water in space. Her research suggests that water formation is a continuous process throughout the galaxy, with new water molecules being created in stellar nurseries around dying stars and in the empty space between solar systems. Water isn't just a local phenomenon, it's a galactic one, possibly a universal one. This cosmic perspective on water raises profound questions about life itself. If water is constantly moving through the galaxy, being recycled from star system to star system, then perhaps life is more connected across cosmic distances than we ever imagined. The water that makes you possible might have previously been part of living systems orbiting distant stars, carrying with it some molecular memory of alien biospheres. Some researchers are investigating whether water molecules can retain structural information across cosmic distances and timeframes. If water's fourth phase can store information, and if this information can survive the journey through space, then interstellar water might be carrying a kind of cosmic library, records of the conditions, chemistry, and possibly even biology of distant worlds. The panspermia hypothesis, the idea that life spreads throughout the galaxy via comets and asteroids, takes on new meaning in this context. Perhaps it's not just hardy microorganisms that travel between worlds, but water itself, carrying information about life from system to system, seeding new worlds with both the substance and the information needed for life to emerge. But perhaps the most radical possibility is that water's seemingly impossible properties, its expansion when frozen, its unusual density curve, its incredible solvent capabilities, aren't accidents of chemistry, but evidence of design. Not design by intelligence exactly, but designed by a kind of cosmic evolution, where water molecules that support complexity and life become more common throughout the universe over time. From this perspective, Earth isn't just lucky to have water. Earth is water's experiment in complexity, consciousness and creativity. We're not separate from the cosmos looking out at it. We're the cosmos looking at itself through water-based eyes, thinking water-based thoughts, wondering about our own watery nature. As you close your eyes and settle into sleep, consider this final mystery. The water within you has traveled farther than any human will ever travel. It has seen the birth and death of stars, witnessed the formation of planets, carried the story of the universe in its molecular structure. You are not just made of water. You are made of the universe's memory of itself, temporarily conscious, briefly aware of the cosmic journey that brought you into existence. Every breath you take contains water vapor that might once have been part of a comet's tail. Every tear you cry returns ancient cosmic water to the world. Every drink you take connects you to the vast flowing story of water's journey through space and time. You are not separate from the universe. You are the universe dreaming of itself through water, awakening to its own infinite flowing nature. Rest now in that knowledge, carried by currents older than worlds, part of a story larger than imagination. Conscious water contemplating its own miraculous existence, the impossible liquid that makes everything possible. And so we return to where we began, that glass of water resting beside you, clear and simple and completely impossible. After our journey through water's mysteries, that familiar liquid should look different now. It's not just H2O anymore. It's a cosmic traveler, a keeper of memories, a living network that connects you to every raindrop, every ocean, every tear that has ever fallen. Water shouldn't exist as we know it. It should be a gas at room temperature. But it chose to be liquid in the narrow range where life can flourish. It should get denser as it cools, but it expands when it freezes, providing a protective blanket of ice that lets life survive beneath winter's surface. It should be simple, but it forms complex networks of hydrogen bonds that might store information, might participate in consciousness itself. Science has given us equations and explanations, but water keeps its deepest secrets. It flows according to laws we understand, yet creates patterns of beauty that seem to emerge from some deeper intelligence. It shapes our planet's geology, drives our weather, fills our bodies, enables our thoughts, and might be carrying messages from distant stars. Perhaps that's the most beautiful mystery of all, that something so familiar can remain so unknown, that something so simple can enable such complexity, that something so common can be so miraculous. Water doesn't just make life possible, it makes wonder possible, makes science possible, makes consciousness possible. As you drift towards sleep, carried by the water within you, remember that you are part of water's greatest experiment, the creation of beings capable of wondering about water itself. You are the universe becoming aware of its own flowing nature, cosmic water dreaming of itself, temporarily organized into the beautiful complexity that is you. Let that thought flow through you like water through a stream, carrying you gently into dreams where the boundaries between you and the vast, flowing universe dissolve, where you become one with the impossible, miraculous substance that makes everything, including dreams themselves, possible. Sleep well, fellow traveler in water's endless story. The ocean within you knows the way home,